and that is erroneous step. Remember this one and follow this. This will be of the form z to the power n minus a to the power n. That means we are moving to the standard limit, algebraic form, and I have used here the standard limit. Limit x tends to a, numerator x to the power n minus a to the power n, denominator x minus a, the value of which is n into a to the power n minus 1. Next I move to sum number 5. Limit h tends to 0, numerator is root over x plus h minus root x divided by the denominator h. Now first step is we put the value h equal to 0 in both numerator and denominator. We find both vanishes, and also we find that numerator is in irrational form. That means we have to rationalize the numerator. Hence this is equal to limit h tends to 0 root over x plus h minus root x. Here the rationalizing factor is root over x plus h plus root x h into root over x plus h plus root x. Limit h tends to 0. The product is x plus h minus x h into root over x plus h plus root x. Here x cancelled. Finally limit h tends to 0, h root over x plus h plus root x. Now h are cancelled since h not equal to 0 as h tends to 0. One thing I like to mention that we find sometimes students are doing this one. This is cancellation due to addition, subtraction. After that, in the same step, they are cancelling h and h. That is not permissible. In one step, you cancel by using addition, subtraction form. Then, in the next step, here we are cancelling using multiplication, division concept. And remember one thing, while you are cancelling by dividing the numerator and denominator, if there be no quantity other than 1, you must mention 1. Very important. I stress on this step. Sometimes we find that students are cancelling h and writing without writing this one, and that is erroneous step. Remember this one and follow this. Now we put finally h equal to 0 in this expression. We get root x plus root x, that means 2 root x. That is the answer. Thus we have solved number 5. Now I solve 6 here. Limit x tends to 0 root over 1 plus x square minus 1 by x. Now if we put x equal to 0, the numerator and denominator both vanish. That means we have to think different method, and since the numerator in this case is in irrational form, we have to rationalize the numerator. Therefore, that will be equal to limit x tends to 0, one plus x square minus 1 whole into root over 1 plus x square plus 1 by x into 1 plus x square root over plus 1. Then limit x tends to 0. The product of the numerator will be 1 plus x square minus 1. Denominator is x root over 1 plus x square plus 1, and we see these ones are cancelled. Limit x tends to 0. We see x is the common factor at the denominator. X 1 plus x square root over plus 1. Now we see x common factor from numerator and denominator we cancel. Mention on the right side since x not equal to 0 and x tends to 0. Then finally we put the value x equal to 0 here. What we get? 1 plus 0 under square root 1 plus 0 plus 0 plus 1, that is half. Next, this sum number 7. Now before solving, I have to discuss another working rule, that is sometimes we have to change the variable. Here we see 1 plus x at the numerator and it has the power n. Now if I change the variable taking 1 plus x equal to say z, then what we see? Z tends to 1 when x tends to 0. Then this will be of the form z to the power n minus a to the power n. That means we are moving to the standard limit. For that, number 7, put 1 plus x is equal to z. Therefore, z tends to 1 as x tends to 0. As x tends to 0, that means we put x equal to 0 here, and what we get? Z tends to 1. Therefore, given limit is equal to limit z tends to 1, numerator z to the power n minus 1. Now at the denominator there is x. From here we get what? X equal to z minus 1. That means it will be z minus 1. Now we get the standard form, limit z tends to 1, z to the power n minus 1 to the power n by z minus 1. This is exactly the standard form. Limit extends to a, numerator x to the power n minus a to the power n divided by x minus a, which is denominator. This is the standard form. Now I can put the result in a to the power n minus 1. Here a is 1. That means finally n. This is the answer. Here I have taken sums on algebraic form. And I have used here the standard limit. Limit x tends to a, numerator x to the power n minus a to the power n, denominator x minus a, the value of which is n into a to the power n minus 1.